This video is on the objective convert from rectangular coordinates to polar coordinates. Right. So in this video, we're going to see that we'll be given a location on the coordinate plane in rectangular coordinates or Cartesian coordinates, x and y first. And then we're going to have to describe how to get to that same location but with polar coordinates, right, with a value of r and a value of theta, right, some radius and some angle. All right, so if you want to see more about the topic, click on More Instruction, and it'll take you to something like this. I'm going to show you some of these notes. You have, watch there's some notes, sometimes videos, examples. Hopefully you go through all those and those help you out. So here we got converting from rectangular coordinates to polar coordinates, right? So from xy to r theta. So to convert rectangular coordinates to polar coordinates, we will use two other familiar relationships. With this conversion, however, we need to be aware that a set of rectangular coordinates will yield more than one polar point. Because if you recall from a previous video, there are infinitely many polar coordinates for a point. There's only one rectangular coordinate pair for a point, but there are infinitely many polar coordinates because all you need to do is take one of them, take one of the r thetas, and then just keep adding 2 pi or subtracting 2 pi, and you'll land right back at the same position. Alright, so here they have some general formulas, and I'll actually draw a little picture up showing you where these come from. Alright, so converting from rectangular coordinates to polar coordinates requires the use of the relationships. The cosine of the angle theta is x over r. The sine of angle theta is y over r. And you've actually seen stuff like this before. It's been probably a little while now. R squared is going to be x squared plus y squared, and the tangent of theta is going to be y divided by x. Alright, so I'll draw a little picture up here showing you, where this comes from, where these formulas come from. Alright, so I've got a horizontal axis, a vertical axis. Now remember, in rectangular coordinates, this horizontal axis is called, the x-axis. In polar coordinates, this horizontal axis is called, the polar axis. Okay, so this is the x-axis slash polar axis. Then the vertical axis, in rectangular coordinates is called the y-axis. And it's called nothing in polar coordinates. Right, and then I'll mark off some integers here. Just a couple. Just 1, 2, negative 1, negative 2, 1, 2. Right. Now, remember in rectangular coordinates. So this is, say we know the rectangular coordinates, right? And we're going to convert to its polar coordinates. So suppose we know the x-coordinate and the y-coordinate of some point. So remember how to travel there in rectangular. I would go from the origin, right, I'd go to the right or left, I'll just say right here, to the x-coordinate on the x-axis, and then I'd go up or down. I'll just make it easy, say let's go up to where we're in line with the y-coordinate on the vertical axis. So there's our, rectangular, this is a rectangle I'm drawing right here, you see that? And 90-degree angles at all corners and all this. But here's the point that we know the location of in rectangular coordinates, right? It has an x-coordinate of x, a y-coordinate of y. Now, if we want the polar coordinates for this same point, well, remember, polar coordinates, you're talking about traveling around on circles instead of rectangles. And these are circles centered at the origin, right? Centered at the pole. So I would like to know what circle this point is on. So that means I need to know how far it is from the origin, right? This was called r, right? The radius of this circle. So if I were to draw a circle, right, on the polar axis, this would be the value r here, right? And I'd be traveling around on this circle, right, with a radius of r, something like that. And here's, negative r on the vertical axis. Here's negative r on the polar axis. And here's positive r on the vertical axis. Right. Well, anyway, and what we've done, remember how to plot points in polar. If I want to find this location, right, I would go to r on the polar axis, and then rotate the polar axis by some angle, right? Travel along this circle by some angle, and this angle is called, theta. So I've got this angle traveled here. Let's just say it's counterclockwise, make it positive, and so again, I'd rotate the polar axis by theta radians, and then this value of r would move up here, and there's my location. Right? This is also r comma theta. All right. These represent, I'll say they're equal, even though they're not the same. They're not going to be the same numbers, but they are equal in a sense that they show you this. They describe the same location. Okay, so now let's talk about all these relationships. Well, look, I've got a right triangle here, don't I? Where this has a length of x, this vertical leg has a length of y, and then the hypotenuse has a length of r. And there's your right angle right there. That's why I drew it in. So remember, in a right triangle, you can use SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you have all these relationships. So the sine, right, the sine of theta would be the y coordinate of our point divided by r, right, the hypotenuse, or the cosine of theta adjacent over hypotenuse, right, would be the x-coordinate of our point divided by the hypotenuse, r again. The tangent of theta, right, the tangent of theta, the opposite over adjacent, the y-coordinate of our point divided by the x-coordinate. Right. And one more relationship that comes from the side lengths. It's a right triangle, so the Pythagorean theorem should hold, and the sum of the squares of the legs should be equal to the square of the hypotenuse. So we have also x squared plus y squared be equal to r squared. Right. So when we're converting from rectangular to polar, right? Say we know what x and y are, and we want to find r and theta. Well, can't really use these formulas, these two, because if I know x and y but not r and theta, here I'll have two unknowns. I don't know what r is, I don't know what theta is. I know what y is, right? I know my rectangular coordinates. So here's an equation with two unknowns. I don't like that. Same thing here, right? This relationship, there's an equation with two unknowns. Don't like that either. So I'm going to separate this out, right? It's these equations. The tangent of theta equals y over x. See, I know x, I know y, and I can find theta now, right? There's only one missing piece. Same thing with this equation. X squared plus y squared equals r squared. I know x, I know y. I just need to find an r. So these equations are going to be used when converting from rectangular to polar. And these equations would be used when you know r and theta, but you want to find x and y. So these two equations will be used when you're going from polar to rectangular. Right, pole to rect. Alright, but for right now we're focusing on going from rectangular to polar. Alright, so actually let me go, now they do draw a picture like that here too. They don't have the circle or anything in there, but so let me go over one example and then I'll go to the question for the problem in the assignment I'm looking at. So suppose we have the rectangular coordinates 3, 3. All right, 3, 3. So I'll draw that here on a separate sheet. So again, vertical axis, and then this is your horizontal, the x-axis slash polar axis. This is the y-axis. All right, and we're given the coordinates 3, 3, right, in rectangular. Right, so x, y equals 3, 3. So we plot that point right here. It is on this rectangle. Right, you can think of, actually it's a square, right? A square is a rectangle. But there's the 3, 3. Right. Now, what I want to do is find out what is a good value of r and a good value of theta that'll take me to the same place. Right. So what is this value here? Call it r, and this angle off the positive x-axis. Remember, we're always measuring angles off the positive x-axis, right? Usually. Okay, well here come those relationships, right? I know that, and basically, so and I'll draw a circle in as well. Here's a, so again we're trying to find this r, right? This circle of radius r that we're traveling on. Right, this might not look like a great circle. I apologize. So then here's r on the vertical axis, negative r on the polar axis, negative r on the vertical axis. Okay. So I know this formula, right? We got r squared equals x squared plus y squared. Right, and I know my x and y coordinates. So r squared is going to be equal to 3 squared plus 3 squared, which is 9 plus 9, which is 18. All right, and then here comes the tricky part. R, right, remember when r squared equals some positive number, r could be one of two different things. R could be positive square root of 18, which is 3 times the square root of 2, right? Square root of 9 times square root of 2. Or r could be negative 3 times the square root of 2. So over here, that's the positive 3 root 2, right, on the polar axis. And then over here, this is the negative 3 root 2. So we're traveling on this circle with a radius of the square root of 18, or 3 root 2. Right. And really, you decide which one you want. For the most part, though, they're probably going to ask you to use a positive value of r. But let's see what happens. Okay, let's see what happens. But before I decide which r I wish to use, let's also find theta, and I also want to find a valid value of theta. So we also have this relationship, right? The tangent of theta is the y coordinate divided by the x coordinate. All right. Now this is just 3 divided by 3, right? We know the y and the x coordinate are both 3. So we have this equation, right? We're solving this for theta. The tangent of theta is equal to 1. All right. So remember, these equations have infinitely many solutions. Theta could be pi over 4, right? The tangent of pi over 4 was 1, plus, and then since the period of tangent was pi, I could take pi over 4 and add any multiple of pi, k times pi, where k is an integer. All right, hopefully you remember solving trigonometric equations, linear trigonometric equations. All right, so I mean, this would be like, pi over 4, then plus pi, be 5 pi over 4. Then, if I go backwards, it'll be negative 3 pi over 4, negative 7 pi over 4, right? All sorts of things. There's all sorts of solutions to this equation. Now, here comes the part where you make some decisions, all right? This is making the decision about r. Do you want to use the positive r or the negative r? So I'll keep this picture up here. Now, what if I use the positive r? Right? If r equals the positive 3 root 2. All right, so if, sorry about the pause there, if r equals, positive 3 root 2, means we're starting over here, at positive 3 root 2 on the polar axis. And then think of, what solution to this equation, this tangent of theta equals 1, would take me to this point. So if I start here, how about, pi over 4? Go positive pi over 4. Remember, positive pi over 4 means you're going counterclockwise 45 degrees, pi over 4. And yeah, that would definitely take me here. This is 45 degrees off the horizontal axis. So theta equals pi over 4 would work. Right? But then you could add any multiple of 2 pi to that you wanted. Right? So I could call this 3 root 2 for r, and then pi over 4 for theta, and that's great. Right? It takes me to that position. But like I said, you could also add or subtract any multiple of 2 pi from that value of theta. If I add 2 pi, that'll be 9 pi over 4. Or if I subtracted 2 pi, that'd be negative 7 pi over 4. And check it, right? 3 root 2, go negative, right? Negative angles are clockwise. Negative 7 pi over 4 would take me to that point. Okay? So, but this is, this is good. All right? So r theta equals, 3 root 2, and then pi over 4 for theta. That's one answer. But that's not all. Right? Like I said, there's infinitely many polar coordinates for any location. So that's if I chose the positive value of r, which they probably will have you do. Right? They probably will have you choosing the positive value of r in most cases. Just got to pay attention, read the directions. What if I chose the other one instead? What if I had r equals negative 3 root 2? All right, well, looking at my polar axis, this circle we're traveling on, if I'm at negative 3 root 2, that means I'm starting over here. Right? I'm starting over here now. Now, will pi over 4 work now? If I start here and travel positive pi over 4, 45 degrees, I'm down here. That's like the total opposite side. Right, here would be the point negative 3 root 2, comma, positive pi over 4. Right, on the total opposite side of the circle. So that's not good. But what would work is if I started at negative 3 root 2 and then go, pi plus pi over 4. So go 5 pi over 4, right? This angle would work. 5 pi over 4. That's another solution to this equation, tangent of theta equals 1. So if I start at negative 3 root 2 on the polar axis and go counterclockwise on this circle, 5 pi over 4, I'm at the same location. So I could also call this point negative 3 root 2, comma, 5 pi over 4. And then from this, I could, if I wanted to, for this theta, I could add or subtract any multiple of 2 pi. If I subtract 2 pi, that'd be negative 3 pi over 4. And take a look at this. If I start at negative 3 root 2 here on the polar axis and go clockwise, so negative 3 pi over 4, I would land at this point. But I'll use the positive angle, right, 5 pi over 4. Okay, so either way, you end up at the same position. So again, it can be a bit tricky. Pay attention to the the instructions though. For the most part, they'll probably just want you to have a positive value of r. They'll probably want you to have a positive value of r and a positive value of theta that's between 0 and 2 pi, right? So you don't go more around the circle more than once. So I would guess that they would probably want this version as an answer. Yeah, so again, a little tricky, but we're still using these relationships that r squared is going to be equal to your x squared plus y squared, and then you're going to be solving this equation, the tangent of theta equals y over x. All right. So let's go to our problem now. All right, I'm going to go to this problem and do the same thing. All right, so this one's a little harder to draw, because 3, 3 was easy, right? I know where 3 on the x is, I know where 3 on the y is. Now you could do a rough sketch of this, but we're asked to find the polar coordinates of a point with these Cartesian coordinates. Cartesian again means rectangular. These are the usual coordinates you're used to, and they're telling you right here it's an x coordinate and a y coordinate. All right, so again, I'll draw a picture of this. Right, as best I can. All I know is that it is in quadrant 3, right? Because both x and y are negative. Right, so again, here's the coordinate plane. And we're given, again, the x and y coordinates. Now, like I said, I don't know exactly. I know this is negative 3.5, and this is negative 3.5 times about 1.7-ish, right? But all I know is they're in quadrant 3. Alright, so I'll put a point down here in quadrant 3 and say, the x coordinate is negative 7 times the square root of 3 over 2. And the y coordinate is, negative 7 halves. There's my, rectangular coordinates. Okay. Now what I want to find are the polar coordinates. How do I travel to the, instead of traveling on a rectangle like this, how do I get there? By traveling on a circle centered at the origin. So first I want to find, what is this radius, right? So again, the value of r here. Now, if I imagine sweeping out a circle with this r, right? So imagine there's a circle. Again, this isn't the greatest drawing in the world, but imagine we're traveling on this circle, right? So we got, here's the negative r down here. It's going to be some negative value r on the vertical axis, the positive r on this polar axis, positive r up here, and the opposite of r over here, right? Negative r. Now the angle we're looking for. usually, remember, almost every time I've drawn an angle, we've wanted an angle that started from the positive horizontal axis, right? So the angle I'm looking for could be, this angle here, and if I wanted to make it nice and positive and counterclockwise. But again, that's not the only angle that I can use, as you'll see in a minute. But for the most part, I will start off with this. I'll try to find this angle that starts from the positive horizontal axis. Right. So that way, if I use a positive value of r, I sweep out that angle, I'll land at this point. Right. Okay, so then the relationships that we're using, right? We got the one is, remember, it's r squared will be equal to x squared plus y squared. Okay. So x squared, that's this negative 7 times the square root of 3 over 2 squared, plus y squared is, negative 7 halves squared. So hopefully you notice that both of these will have 49 fourths in common. Right, there'll be 49 fourths times 3. This will be 49 fourths times 1. So I have 49 fourths I can factor out. And then there'll be 3 left over here, plus 1 left over there. And then the 4's will cancel. This is, 3 plus 1 is 4. So I'm getting 49. R squared is 49. And so R can be 7, or R can be negative 7. So on the polar axis here, this value is r equals positive 7. This value over here is negative 7 on the polar axis. All right, now let's think of solutions to that tangent equation. Right, we have this other relationship. The tangent of my angle theta, whatever angle I choose, has to be the y coordinate divided by the x coordinate. Now, if I take this y coordinate divided by this x coordinate, do you see how the negative 7 over 2 would cancel? And I just have 1 over the square root of 3, which, rationalizes the square root of 3 over 3. And again, there are infinitely many solutions to this equation. I'm just trying to find the best one that'll take me from positive 7 to this point, or take me from negative 7 to this point, which would be a much shorter distance, shorter travel. All right, so here, theta, now again, it's a tangent, so just think of one angle that makes this true, and then just keep adding pi, right, because the period of tangent is pi. All right, well, one angle that had a tangent of root 3 over 3 was pi over 6, right, 30 degrees. Pi over 6 radians. And then again, since the period of tangent is pi, I could just keep adding k times pi to this, right, where k is any integer. All right, so let's think. Again, I listed a bunch of solutions last time. This time I'm just going to start with, does pi over 6 work? And if it doesn't, then I'm just going to keep adding or subtracting some multiple of pi until I get to the point that I want, this point right here in the third quadrant. All right, so what if I chose the positive value of r? Right, if r was equal to positive 7. Well, that means I'm starting here on the polar axis. And if I start here, well, let's think. Does pi over 6, right, that one solution to this equation, does pi over 6 take me to that point? Let's see. So pi over 7, if I start at positive 7 and travel, pi over 6 radians, and I know it looks like more than 30 degrees, but if I they should form a straight line here. If I travel pi over 6 radians, sweep out pi over 6 radians, I'm landing here. There's the point 7 comma pi over 6. That is not this point. But all I would need to do is add pi. All right, it takes me to the other side of the circle. So if this is 7 pi over 6, I just need to go another pi, and then this would be 7, and then pi over 6 plus pi would be 7 pi over 6. So I could use theta equals 7 pi over 6 when my value of r is 7. All right, so there are the polar there's one version of polar coordinates for that location. Now again, I could also take this 7 pi over 6 and just add 2 pi. Subtract 2 pi, right? Go all the way around the circle and get there again. So that'd be fine as well. Now what if r were -7? Well, then I'm starting over here on the polar axis, right, where r is -7. And let's see, does pi over 6 get me there? Well, starting at -7 and then going positive pi over 6, so counterclockwise pi over 6, yes indeed, that would take me to that point. Right? So this is also the same as r equals -7, theta equals positive pi over 6. You could use that as well. Right? It really depends on what they want you to do. Right? Again, here is just a multiple choice problem. In other questions, they may ask you to find the polar coordinates. If you're given the rectangular coordinates, find the polar coordinates that take you to the same point, but use a positive value of r and use a positive value of theta, between 0 and 2 pi. So let's see which one of these choices works. So we had, 7 pi over 6 was one of those. Right? Takes me to that point in polar. This is the point in polar, this is the point in rectangular, but they are the same location on the coordinate plane. Right. Wonderful. And again, please read your answer explanations. Now, I like drawing pictures. I like drawing pictures because it's very easy to see if I land at the point that I'm looking at. I want to know what quadrant I'm in and stuff like that, what circle I'm traveling on. Alright, so hopefully watching me, this is a longer video because it was the first one in this objective. I went over some of the instruction, I went over a couple examples. I'm hoping my going over these couple examples here and looking at the more instruction, reading the answer explanations when they come up. I'm hoping all this stuff helps you out when you work on this material on your own. And thank you very much for watching.